Hi everyone, this is Stefan. I wanted to take a minute here to run through a little exercise here and understand a little bit closer of how Git works under the hood. So we're going to go through an exercise and do some fairly basic things with Git, but then we're going to run some commands that show us internally what's happening inside that mysterious .git folder. Hopefully by getting a better understanding here, it'll make you more effective working with Git moving forward. So the first thing we're going to do is we're going to make a directory. We'll call it how Git works, and then we're going to move into that directory. To initialize a Git repository, we use the command git init, and that creates the .git folder inside of our repository. Now we're going to put the string 1 inside of a file called 1.txt, and we're going to tell Git about it by adding it to what's called the stage. Now we're going to use a command here. This is not a command that you're going to use every day, but it shows what's happening inside that .git folder. So this command, git ls files, will list all of the files that Git knows about, and the -s option shows us all of the files that are in that stage. So we've added our 1.txt file, so what we expect to see, and what we end up seeing there, is that we see 1.txt. Now, Git uses SHA hashes to identify all of its objects. So this value right here, that is the SHA hash for that 1.txt file. So let's have a closer look about what that actually is. So we're going to use another command here. And we're going to have a look to see specifically what is in this file. So this command catfile -t outputs the type of file that particular SHA is. So this file, as you can see there, is a blob. So a blob is Git's internal representation of a file that it knows about at any given point in time. We can use a variation of this command where we can say -p, and that'll give us the contents of that blob. So then now we can see we run that, and we see the contents 1 that we put in. Now what if we were to change the contents of that file? So let's take the string 2 and put it into the same file, and we'll add it to the stage so that Git knows about it, and we're going to rerun our same command here. So now think about what we expect to see. So after running that command, we can see that there's still the string 1 in that file. So what actually happened to the 2 string that we put into that file? Let's have another look at the files that Git knows about, and we'll see now that the same file exists, but with a different hash. So let's have a look inside that file. And we'll see there's our string 2. So what this is showing us is that blobs in Git are immutable, meaning that if we change the contents of a file and then add it to our stage, a new blob is created. This is a very powerful concept within Git, and really is the fundamental reason why when we're working in Git, we can always get back to a good state no matter how bad we mess things up. Because we have never actually deleted anything, we've only added new stuff to Git. So let's move along here, and we'll put our value 1 back into this file, and we'll add it to the stage. And now let's look one more time at the files that Git knows about. Now you'll notice that this hash here is actually the same hash that we saw up above. Now what this is saying is that Git actually uses the contents of the file to create the hash for the blob. So because we put the exact same text in, Git knows that it's equivalent to what we had originally, and therefore it'll use the same hash. So This is one of the efficiencies that Git uses to save on space. Instead of creating new blobs that are identical, it just reuses the old blob. But again, nothing has been modified, and it cannot be modified. It would create a new blob if it were. So that's a little bit about blobs, but now let's actually do something with Git here. So we will commit our file here. So now let's look at a few objects that were created. You'll see here that we're on the master branch. And so there's a special file in Git that'll tell us what specifically that means. So let's have a look at that. So it's in the Git folder, in refs, heads, and then the name of the branch. And so now here we see another SHA. So let's have a look what that one is. We use the -t switch, and this will tell us the type of the file. So now we have another object type in Git here called a commit. You're probably already familiar with this term, but let's have a look inside that file to see what its contents are. So we can see that it references a couple things. So it references the tree, and it gives us the SHA there, and then there's some metadata about the commit, namely that I made it, and the commit message there of first commit. So let's have a closer look at the tree reference there. Again, this is another object type here. So let's have a look at that. So cat file -t, and we'll grab the SHA. Not unsurprisingly, it tells us that the file type is a tree, and then we look inside and we see it's a reference to the blob that we created. So a tree is essentially a snapshot in time of a folder. In this case, our root folder here has one file in it, 1.txt, and that's it. Let's do something a little bit more interesting. So let's create some more files. Create a 3.txt, and hey, our application's going to expand here, and we're going to create some letters. So let's put those letters in another folder. And we will add all of those files to our stage, and we'll create a commit. We'll call it second commit. Now let's have a look at our refs file for master again. And so we have a new reference to a different commit here. So let's have a look at that one. And we'll look inside the file. And so, well, first of all, let's notice we see something different here. The structure is different than the first commit that we did, because now we see the additional field there of parent. So the first example was special because it was the first commit. Every commit now after this is going to have a tree and a parent. Some commits, like merge commits, will actually have two parents. But the key concept here is that a commit is made up of a tree. Remember, that's a snapshot in time of a folder, and the commit that came before it. Let's have a closer look at this tree. So let's just grab the SHA here. So the first thing I notice here is that our 3.txt file is missing. Let's find out why. If we scroll up, oh, look at that! I missed the greater than sign. That's okay. We can just ignore that. So we see that our tree here now has two blobs in it, 1.txt and 2.txt, but it's also recursive in that it has another tree reference. And then if we were to look at that tree, let's have a look here. Use the new blob or the new SHA reference, and we see that it internally has a blob there. So trees can be recursive in that trees are made up of n number of blobs and n number of trees, and so then we can represent the entire folder structure of our repository just by referencing a single tree. So looking back at the commit that we're on again, just to rerun this command, we can now see again that a commit is a combination of a tree and a parent. So just to quickly review, we looked at different object types within Git. We saw blobs, blobs being a snapshot of a file at any given point in time. We looked at trees, trees being a snapshot of the blobs and other trees that are contained within it. And we saw commits, commits being a combination of a tree and the commit that came before it. So all three of those objects, if we remember, they are all immutable, meaning that once they are created, they can never change. If we want to affect change within our repository, we need to create new instances of those objects, and Git will do that for us. And then the last object that we looked at very briefly there was the ref for the master branch, and that is always just a pointer to the SHA of another commit, and that is mutable. So obviously our branch will change which commit it's pointing at over time, and so that needs to change along the way. So that's a quick look at how Git works internally inside that .git folder, and hopefully that helps you gain a little bit more understanding. If you have any questions, drop in the .git Slack channel, and we'd be a lot of Git experts there, happy to help you out. Thank you very much. Until next time.